In this video, we are going to teach you how to differentiate a function with respect to another variable. For example, we have a derivative of x to the power 5 is 5x raised to 4. Derivative of, let's say, u raised to 7 with respect to u is 7u raised to 6. What you notice is both of them are same. That is, variable of differentiation, the base of the function, both are same, then we can apply this formula directly. What about if u is not a constant, u is a function of x, then, but I want to differentiate u with respect to x. For example, u may be 2x plus 3. U is a function of x, u is not a constant. I want to differentiate u raised to 7. See the technique? What I do is, it's something like divide and multiply. D by du of u raised to 7, I put a du extra into du by dx. Now they became same, so I can apply this formula. So my answer will be 7u raised to 6 into du by dx. We need to learn this as a formula. This is a technique of finding the derivative. D by dx of u to the power n, any function with power n. First, differentiate u raised to n with respect to u. Differentiate u raised to n with respect to u. So d by du of u raised to n into du by dx, which means n u raised to n minus 1 into du by dx. This is what we are going to learn here. We are going to learn the application of this formula. Now let's have a look at the one by one. So my aim is now to train you in this formula. I'm writing the formula once again. D by dx of u raised to n is, first differentiate u raised to n with respect to u, that is n u raised to n minus 1. Don't stop with that. Again, differentiate u once more. U stands for the base. So if I want to differentiate x squared plus 1 raised to 7, so your u is x squared plus 1. When I'm differentiating with respect to 7, if I apply 7 over here, start with the 7, x squared plus 1 raised to 6, power is reduced by 1, into d by dx of u. What is u here? U is the base. What is the base here? X squared plus 1. So once again, have a look at u raised to n is n u raised to n minus 1. So 7 u raised to 6 into derivative of u. What does u stands for? The base, x squared plus 1. So my answer now became 7 x squared plus 1 raised to 6. Now derivative of x squared with respect to x. So both are same. So 2x. Derivative of 1, 0. So can be written as 14x into x squared plus 1 raised to 6. This would be my answer. So once again, let's look at it once again. Whenever a function you have a power, start from the power, reduce the power by 1 as usual into derivative of the base. So let's have a look at another question. Let's say I have d by dx of sine cube x. Now what is the power here? 3. So it is similar to d by dx of u cube. You can see that base is x, but here the base derivative is with respect to x, but base is not x. So we cannot apply direct formula. If they both are different, 3u square into derivative of u. So derivative of sine cube x will be, start from where? Start from the power, 3. Then what should I do? Reduce the power by 1. Then don't be happy with that much. Then what more? You need to find the derivative of the base. What is the base here? Base is sine x. So base is sine x. So derivative of sine x. So your answer became 3 sine square x into cos x. Now let's have a look at another function, another example. Now I'm going to put many questions together and let's see how. Now I start with the function 1 upon x squared plus 1. Whenever we see 1 upon, you always get a confusion whether it belongs to the power rule. It belongs to power rule only if it is u to the power n. So we can write this as d by dx of x square plus 1 raised to minus 1. Now this became power. We can apply this formula. What will be derivative of u raised to minus 1? Minus 1, u raised to minus 2 into derivative of u. So if you apply the formula, minus 1 into x square plus 1 raised to minus 2 into d by dx of x square plus 1. So my answer will become minus 1 into 1 upon x square plus 1 the whole square into derivative of x square, both same, so 2x, and derivative of 1 is 0. So my answer is minus 2x upon x square plus 1 the whole square. Now let's have a look at derivative of root of cos x. I need a little more space, so let me write a little down. d by dx of 1 upon root cos x. So first you need to express it as a power. So I can write d by dx of cos x raised to, root means power is half. When you take it to denominator to numerator, minus half. So cos x raised to minus half. So again, power rule. Start from what? Start from the power. Minus 1 by 2. Cos x raised to minus 1 by 2 minus 1. Minus 1 by 2 minus 1. Minus 3 by 2. Minus 1 by 2 minus 1. When you take LCM, minus 3 by 2. Into, after calculating the first part, n into u raised to n minus 1, what more? Into d by dx of cos x. So your answer became minus 1 by 2 raised to minus 3 by 2 means cos x raised to 3 by 2. Derivative of cos x minus sin x. Formula for derivative of cos x is sin x, same. So direct formula. So I can write now this as this minus and this minus will become plus 2 into cos x raised to 3 by 2 is cos x root cos x. And this sin x I can combine with 1 and write as sin x. So your answer is sin x upon cos x into root cos x. Let's try to differentiate this function. d by dx of x square plus sin square x raised to 7. So this we can see very interesting in this particular problem. First, this is u raised to 7. U raised to 7. So what is the derivative of u raised to 7? Derivative of u raised to 7, start from 7, reduce the power by 1 into derivative of the base. So let me apply the same way. Start from the power, 7 into x square plus sin square x is the base. Reduce the power by 1 into derivative of the base. What is the base here? This whole thing is the base. X square plus sin square x. Now this became 7 into x square plus sin square x raised to 6 into, now I am continuing with the bracket. Many of the times I've seen students forgetting the bracket and then not getting the answer. Remember, when you find the derivative, the bracket will remain. Only derivative will go inside. d by dx of x square plus d by dx of sin square x. So remember this, the bracket is very important. Do not delete the bracket. If you delete the bracket, your answer will be entirely something else. So 7 into x square plus sin square x raised to 6. Bracket remains. Derivative of x square 2x. Now let's see derivative of sin square x. Most of the time, students, when I say derivative of sin square x, they'll say cos square x. There's one mistake they say. Sin x derivative is cos x, but sin square x derivative is not cos square x. Sin square x will come in power category. It is sin x the whole square. Sin square x means sin x the whole square, which means it is a power category. So start from the power. 2. Reduce the power by 1. So you usually don't write power 1. Into derivative of sin x. This is the second mistake students do. They forget to write the derivative of sin x. What is the derivative of u square? 2u raised to 1, derivative of u again. 2u into derivative of u again. So derivative of the base has to be done again. So your answer is 7 x square plus sine square x raised to 6 into 2x plus 2 sine x, derivative of sine x is cos x. Now if you want, you can use a trigonometric formula here. So 7 into x square plus sine square x raised to 6 into 2x plus sine 2x. From where you got sine 2x? 2 sine theta cos theta is sine 2 theta. You can use that formula, trigonometric formula. This is how you have to find the derivative of x square plus sine square x raised to 7. Once again, first you start with this power. So always ask how to start the derivative. Start from the power. Reduce the power by 1 into derivative of the base. Then forget about this part. Just cut and paste the same again and again. Then we have to look at this part. Derivative of x square, same, base is x. Derivative with respect to x is same, so 2x. Then derivative of sine square x, again power rule. Start from the power. Power into, reduce the power by 1 into derivative of the base. Remember the bracket. If you forget the bracket, what will happen? If you forget the bracket, what will happen? It means this 2x will multiply only this. This term will not multiply this. Hence your answer will go wrong. Hence this bracket is a must. Bracket is the most important mistake that you most commonly done. Let's try to do this problem. You need to find derivative of x square plus 1 the whole cube into sec square x. What are the operation? There are two terms here. This is one term, this other term. They are connected by the multiplication sign. And you remember, whenever we want to apply derivative of u multiplied with v, what is the technique we do? The first function as it is, derivative of the second, plus second as it is, derivative of the first. So we need to apply this product rule here, because the function between the operation between the function is product. So we will start with which is the first function. This is the first and this is second. So first function as it is, x square plus 1 the whole cube. First function as it is, derivative of the second plus second as it is, derivative of the first. So we applied the product rule. So this is very important. Till now all the problems we had plus sign or minus sign. So there was no need to apply product rule any of the problem we have done today. But this is the first problem where we are applying the product rule, because the function between the two functions, the operation is product. Now we'll see each one. X square plus 1 the whole cube, derivative of sec square x. So derivative of sec square x means power rule. Sec x the whole square it is. Power rule should start with the power. Power rule starts with the power. 2 sec x, power reduced by 1 into derivative of the base. What is the base of this? Base is sec x plus sec square x as it is. Now again we have to apply power rule. Power is, how much is the power here? Power is 3 here. So start from the power 3. X square plus 1 the power reduced by 1 into d by dx of the base. So always remember d by dx of the base. So now my answer became x square plus 1 the whole cube into 2 into sec x. Derivative of sec x. Recap the formula. Derivative of sec x. Sec x into tan x plus sec square x into 3. I'll write this. Okay, then sec square x into 3 x square plus 1 the whole square. Now the sign between them is plus. So if it is plus, directly you can apply each one. Derivative of x square, 2x. And derivative of 1 is 0. So there is only one term here, so I'm not putting the bracket. But if you feel like, you can put the bracket. Now we'll take the common. X square plus 1 the whole cube and x square plus 1 the whole square. X square plus 1 the whole square is common. Then 2 is common, number 2 is common, so I'll write 2. Then sec square x and sec square x is common. So sec square x is common. Now I'll say what is in the bracket. There is x square plus 1 the whole cube, but I took only x square plus 1 the whole square. So 1 x square plus 1 will remain. Again, sec square x and x square plus 1 the whole square and 2 is removed. What is left is 1, 3. Then 2x, x will also be remaining. So 3x will remain. So x square plus 1 from here. Then a tan x also is remains. So x square plus 1 into tan x plus this is common, sec square x is common, 2 is common, 3x. Now we'll check once again whether I've done it correctly. 2 x square plus 1 the whole cube into sec square x into tan x. That first part is correct. Second part, 3 times sec square x, x square plus 1, the whole square, 2 into x. So the answer is correct. This is how you need to apply. So what I showed you is, in the power rule, how do you apply the product? So between the terms, if it's a multiplication, you need to do product. If the between the term it's a division, then you have to apply u by v method. So every time you have to check what is the basic operation between the two variables. Multiplication, you need to apply the product rule. Now we will see how we can apply for functions with a square root in a very fast method. We do not want to write raised to half and take a long term, so we'll apply a short method. Suppose I want to differentiate u raised to root of u. Naturally, I need to apply d by dx of u raised to half. Now we'll apply this formula. Half u raised to half minus 1. Half minus 1 is minus half into derivative of u. Use the same formula. Now this I can reduce it. 1 by 2. U raised to half is 1 upon root u. Half is root minus in denominator into d by dx of u. So fast way, 1 by 2 root u into d by dx of u. You will remember I have taught you derivative of root x is 1 by 2 root x. So in place of this x, if I have u and I am differentiating with respect to x, what will be my answer? 1 upon 2 root u into one more term. Derivative of root x is 1 by 2 root x if the variable and the base are same. But here variable and base are not same. Inside the root you have u, but differentiation is with respect to x. So you will have one more extra term, d by dx of the base, d by dx of u. So look at the derivative of root sin x. You don't have to write sin x raised to half. Directly you can write 1 by 2 root sin x into derivative of sin x. I want you to master this. I want you to always do this directly so that you save a lot of time, especially in a complicated function. Directly we need to apply. Remember, I'm trying to teach you this topic so that you can calculate it fast. So 1 by 2 root sin x into cos x becomes your answer. So let's practice few more. So remember, derivative of root u, 1 by root comes into denominator. Whatever here comes to denominator. 1 by 2 root u into derivative of the base, derivative of whatever inside the root. Let's practice few problems in this. I want to calculate, so let me change this formula now here. Derivative of root u, derivative of root u. 1 upon 2 root u into derivative of u. This is my formula that I'm going to apply in all the problems. So let's practice around 10 problems fast. D by dx of root of log x. Root log x. So our formula is half is the power. That means 1 by 2 will be there. So 1 by 2 raised to half minus 1 become minus half. So directly root of log x into derivative of log x. So your answer is 1 by 2 root log x into 1 by x. D by dx of root of, let's say, cos x square x. Derivative of cos x square x, root of cos x square x. Square means cube because it's already. You can do one method. You can write cos x raised to 3 by 2 dx, x dx and apply the formula. You can also apply this method. Whichever you feel convenient, you can do it. Just to teach you, I'm applying it. 1 by 2 root cosec cube x into derivative of cosec cube x. It may not be a faster method, but you can do it in this way also. 1 by 2 cosec cube x. Now derivative of cosec cube x. It's a power rule. Start from the power. 3 cosec square x into derivative of cosec x. So your answer became 1 by 2 root cosec cube x into 3 cosec square x. Now derivative of cosec x is minus cosec x into cot x. So I just you could have done cosec raised to 3 by 2 and did the problem. But just to make you understand the concept of how to apply with the square root, I've taken this example. derivative of root of, okay. Remember, whenever the question that will be given in your book will be differentiate root of x square plus a square with respect to x. This will be the problem that will be. Every time the question, the examination and the homework assignment will be written like this. You need to start with let y equal to. We have been doing this in all problems that I have taught you. Always start let y equal to, so that the derivative and the function don't become equal. Then you differentiate. What operation you are doing? Differentiate with respect to x. When you what is the notation for differentiate? D by dx, because derivative is with respect to x. What you are doing? You are finding the derivative of y, so it became dy by dx is equal to d by dx of root of x square plus a square. Now we think about the formula that I've taught you. Root, square root. One method is raised to half, you can write and apply the power rule. Another method is you may apply this formula directly. It is easy to apply this formula directly, and I want you to learn that way. So 1 by 2 root u x square plus a square into d by dx of the base. What is the base here? X square plus a square. Now that is 1 by 2 root x square plus a square into derivative of x square plus derivative of a square. Now remember, whenever I give you a function in x, whatever the alphabets given other than x are all constants. So here a square is a constant. Otherwise they should give us a is a function of x. If nothing is given, a square is a constant, so derivative will be 0 here. So 1 by 2 root x square plus a square, derivative of x square is 2x, derivative of a square is 0, so I'm not writing it. So 2 and 2 will get cancelled. So final answer x upon root of x square plus a square becomes my final answer. So every time root is there, directly apply 1 by 2 root x square plus a square. Now in the assignment, I have given a lot of examples and also homework. Complete them sincerely. First you try yourself, then check with the answer of the solved example. First you have to complete the solved example, then do the assignment and send the assignment on WhatsApp. Also, don't forget to put like in your videos. I would like to see that number of likes are good.